about what we found as far as non-fiber carbohydrates in alfalfa or mountain hay. Um, and what are non-fiber carbohydrates? Why are we interested in them? So I wanted to compare what we're talking about to what we see on just regular food labels. When we get our forages analyzed, it'll tell us how much fat there is, how much carbohydrate is present, and partly as fiber or neutral detergent fiber. And also, there's a category of non-fiber carbohydrates that includes sugars and starch, and also pectin, which is in the cell wall, but it's highly digestible by rumen microbes. We also can find out about protein, and we know that good alfalfa hay has protein up around 25% of its dry weight. So all of these are the proportions of these elements in forages. But I'll talk about fiber first, and then I'll talk about non-fiber carbohydrates. So we know, comparing alfalfa, this is a study that was done using second crop hay from a mixture of alfalfa and timothy. It was done in Wisconsin. And so we know from that study that alfalfa is about almost half leaf material and about half stem, while timothy has only about 30% leaf and 70% stem. And we also know that the fiber in both the leaves and the stem of grasses is going to be higher than it is in legumes like alfalfa. So overall, we've come to expect legumes to have about 50% fiber and grasses to have more than that, 2/3 to 3/4 fiber. And what we know about fiber is that the more fiber there is in a feed, the slower the digestion, and therefore the lower the intake can be. That's great if we're creating a ration, but if we're finishing animals in the field, it may be of more interest to know how much energy we can get in our forages. One more study just to talk about what we come to expect in terms of fiber. This is a study that was done in Missouri, and it's showing 2 years, and these are 2 years of legume pastures. This happens to be bird's foot trefoil, and grass pastures, and in this case they were separate. And you can see that they changed from year to year, but again, the bird's foot trefoil had a fiber concentration of about 50%, and the grass ranged between 65 and 75%. So we got better gain in this study on the legume than on the grass, and it's because of the high digestibility of the legume. So then I'm going to shift to studies that we've done here in Cache Valley. This is a study this photo was taken in 2011, but the data are from a study that was done in 2013 on pastures like this. We had 3 treatments. We had animals that all started out at the same rate. They were yearlings, so they were all about 1,000 pounds. And we slaughtered them in September. And the treatments they had been on were either a feedlot treatment, a legume treatment, the bird's foot trefoil like the Missouri study, or a grass. And in our case, we were using meadow brome grass. And what you're looking at here are the beef carcass weights. And the letters are showing us that there was no significant difference between the carcass weights, between the feedlot treatment and the legume pasture treatment, but they were both higher than the grass-fed or grass-finished treatment. And we slaughtered the animals, we took the steaks, and we put them into a sensory panel or a taste panel. And one of the things we were most interested in are things that are relevant to grass-finished beef. And the complaint sometimes is that the meat is not as tender as grain-finished beef, or that it's not as juicy as grass-finished beef, and that has to do with the amount of intramuscular fat, and that has to do with the amount of available carbohydrate during finishing. And so what we can see here again is that the feedlot and the bird's foot trefoil finished beef were not different, but they were both higher than the grass for tenderness, same thing for juiciness, and for the overall appeal of those steaks. So we compared the diets, we did the analysis of them, and we generally don't measure non-fiber carbohydrates for forages, but we almost always measure fiber, and so you can see that the fiber amounts or percentages in the feedlot diet, which is called USU grain here, and the legume diet, USU bird's foot trefoil, were pretty similar, both around 30%, and the grass was higher, 50%. These are all lower, though, than what we've come to expect from studies that were done in Wisconsin or in Missouri. And then if we look at the non-fiber carbohydrate, this was a surprise. I hadn't put things side by side like this until we did this study, but we can see that the non-fiber carbohydrates, so that would be the sugars and the starch, combined with pectins and other things that are soluble and readily accessible to rumen microbes, were about 40% of the dry weight, while in the grass it was about 20%. So that's a big difference, and that's a lot more energy than we've come to expect from forages. So I just want to orient all of us in terms of what we can expect from other components of feed rations that are commonly used. So these are data from a study that was done in California, where the scientists went to almost 40 commercial dairy farms and collected samples of feed rations. We're looking at the mean of these rations, and I'll just focus on the fiber again. So you can see alfalfa hay from this study had a non-fiber carbohydrate concentration of 26%. The alfalfa silage in the same range. Corn grain down here, as we would expect, is about 75% non-fiber carbohydrate, because that's the source of starch in these diets. But if you look at the beet pulp and the corn silage, what you see is that they're in this 40%, 35 to 40% range that we saw in our forages, in our pasture forages. So then I'll show you this comparison. All of these forages were harvested in Cache Valley in 2016, so we can look at them side by side. They weren't done in the same fields, of course, but we have samples of hay, and this is first crop hay that was cut at the beginning of June, or pasture, and these are composites of pasture that were collected over the grazing season. So that would be comparable to what our animals were consuming in that finishing study over the entire, I think it was 111 days that we had them on pasture finishing them. But look at the non-fiber carbohydrates. So the first four here are legumes, and they're all falling between 35 and 40% non-fiber carbohydrate. But the grass is much more similar to what we see in other environments. And then when we look at the pasture material, and we take our material from the pasture and we freeze it, and then we freeze dry it so we don't lose any of the carbohydrates that the animal would be getting in the pasture, these get up between 40, almost 50% in some cases, percent of their dry weight that is non-fiber carbohydrates. And so we want to check these. These were done in the lab with a relatively quick method. It all checks out so far, but we're taking a deep dive to confirm these levels before we try to publish anything. But again, you can see the grass is higher when it's in the pasture than when it's cut as hay. And so then the question is it due to altitude? And so Matt Yost had alfalfa samples that were cut at 5,000, 6,000, and 7,000 feet in altitude, whereas at Cache Valley is closer to 4,500 feet. But you can see that we're still, with alfalfa hay, in the range of 35 to 40%. So what we think is that these high non-fiber carbohydrate values are a result of these plants growing under irrigation, long sunny days, even when we're providing the water. It's not from rain, and so we don't have clouds. And we always have cool nights. And if you've lived in the Midwest, you know that's not typical in a more humid climate. So we want to know where these, I'm a plant physiologist, I want to know where in the plant and when this is accumulating. So we have samples from a publication for New York State, and we took samples in Utah, and we're looking at total non-fiber carbohydrates. So you can see that our leaves and their leaves in New York are the same. But if you look at stems, the non-fiber carbohydrates in New York are less than 15%. Here they're above 35%. So the components of these non-fiber carbohydrates are sugars, which are shown here, starch, something called organic acids, which are generally fairly low in concentration, and then soluble fiber. It's kind of a contradiction, but it's accessible to rumen microbes. That's the important part. You can see it's quite a bit higher in the leaves of the New York alfalfa than in the stems. And by subtraction, we can see that our sum of organic acids and soluble fiber is around 26%. So what we see, a big accumulation of soluble fiber or pectin have plots at Lewiston that are 2 acres each, and we have 4 of those for both alfalfa and then 4 for meadow brome grass, and we're looking at the yield and the quality. 3 harvests taken at 42-day intervals, but in between, every 2 weeks, we're looking at whole plant, stem, and leaf analysis of the non-fiber carbohydrates in those plants. What we expect just from studies that are, this is from West Virginia, so this is the classic graph of what happens over the time between regrowth starting and maturity of the plants, is that the leaves and the protein will decrease, and the stems and the amount of fiber or NDF in these plants will increase. So we're going to add something to this classic graph. We're going to add non-fiber carbohydrates in our mountain grown hay so that we can see when and where in both grasses and legumes these two components, or these components of the non-fiber carbohydrates, are developing to such high levels. So I'll just end by saying I think that what we can use this information for is to increase the value of mountain hay. It's always had a reputation for being very high quality, but I don't think anyone has tried to sell it as also having very high energy. So if we have growing in the field alfalfa that is in composition more similar to beet pulp or corn silage, then I think it's good to know about it. So if there's time, I'm happy to take questions.